Now, let us draw the electric field strength on the charge. Okay, electric field strength on the charge. So now, as we learned before, okay, as we learned before over here, electric field strength only depend on one charge, which is the point charge, the big Q. Yeah, because the formula only has big Q, point charge. The test charge already being divided away. So only left with the point charge, KQ over R square. Okay, so yeah, only depend on point charge. So if positive point charge, the electric field is outward. If negative point charge, it is inward. Okay, now let us sketch the electric field strength on charges. Now, let us look at the first one. Okay, can you see it? Yeah. Now, electric field. Okay, I have here. I have yeah, follow the same chart just now. You have Q1, Q2, Q3, Q4. Okay, now the first question, sketch the electric field strength on Q1. On Q1. So, I want to sketch an electric field strength. Last time is sketch what? Last time is sketch the electric force. Last time is sketch electric force. This time it is sketch electric field strength. It is different. Okay, sketch electric field strength. Sketch electric force. You look at both charge, two charge. If positive, positive, repel. If positive, negative, attract. But for electric field strength, only look at point charge, only look at one charge. If positive is going outward, if negative is going inward. That's it. Now, sketch electric field strength on Q1. That means experienced by Q1. Yeah. Here it doesn't mean that electric field strength of Q1. No. Here actually it means that electric field strength experienced by Q1. Yeah, experienced by Q1. That means Q1 is inside the electric field of Q2, Q3, and Q4. Actually, all these four charges, they all give out their own electric field. Yeah, Q1 give out its own electric field going outward. Yeah, maybe I should draw it. Draw it over here. You know that actually Q1 emit the electric field outward. Yeah, emit. Q2 also has its own electric field. Yeah, has its own electric field. Q3 also has its own electric field going inward. You know that? And Q4 also has its own electric field going inward. Yeah, all of them has their own electric field. But now I want to draw the electric field strength experienced by Q1. Electric field strength experienced by Q1. That means Q1 is inside the electric field of Q2, Q3, and Q4. Okay. Yeah. Q1 also has its own electric field. Yeah, I know, but we don't look at Q1. Yeah. Right now, Q1 is the test charge. Q1 is the test charge. So the other charge, Q2, Q3, Q4, they are the point charge. They are the point charge. So now let's draw the electric field of all the point charge. Okay, experienced by Q1. Okay, Q1 is inside the electric field of Q2, Q3, and Q4. So how to draw the electric field strength on Q1? Yeah. So now for Q2, okay, Q2, the electric field strength is because it's positive, isn't it? Positive is going away from the positive charge. So over at the Q1, okay. So remember, for electric field strength, only look at what's the formula? Let's write the formula. Write down the formula. Electric field strength is KQ over R squared. So it only depends on the point charge. Only look at the point charge, the one who gives the electric field. Okay. So all right. Now for Q2, electric field is going away, isn't it? Going away. So at the position Q1, Q1 is a test charge. Over the position of Q1, the electric field provided by Q2 is in this direction because going away. Yeah, because electric field of Q2 is going away. You know that? It's going away. But you don't draw that. Yeah, going away. So you just put this as E2. So you see, when I draw E2, I only look at Q2. I don't look at Q1 because I only interested in electric field of Q2. Q2 is positive, so it's going outward. So at position Q1, it is like going away from Q2. Going away from Q2. Okay? Now, how about Q3? Q3 is going inward. So that means E3 is going towards Q3. This is E3. E3. Just write E3. Don't write E31. Don't write E31 because it only depend on point charge, only depend on one charge. Don't write E31. The force, if the force, you write F31. But if electric field only depend on one charge, which is the point charge, so you only write the subscript for the point charge, only one charge, only one number. Okay, E3. And then Q4 is inward, so it is the E4 is towards the Q4. So this is the E4. Do you see that? When I draw E2, E3, E4, I only look at the point charge. I don't look at test charge. Q1 is the test charge. Q1 is the test charge. I don't look at test charge. You know, even you don't have the Q1 here, if this Q1 is not existing, yeah, if there's no Q1 here, if there is no Q1 here, the E2, E3, E4 still exists. You still can find electric field at this point, at the position of Q1 over here. If the test charge is not there, what I mean is if there's the test charge of Q1 is not there, E2, E3, E4 still exists. If force not exists, force must depend on both charge. But electric field only depend on point charge. So if test charge is not available there, E2, E3, E4 still available. Yeah, E2, E3, E4, the electric field is still there. Because electric field is provided by the point charge. It's not provided by the test charge. Electric field is provided by the point charge. So if the test charge is not there, the electric field are still there because they are point charge. There are still point charge who provide the electric field there. You understand what I mean? Okay. So what is the means by what's the difference between point charge and test charge? Point charge, the point charge is the one who provide the electric field. Test charge is the charge that inside or experience the electric field provided by the point charge. If test charge is not available, the electric field is still available because the point charge is still there. You understand? So that is means by if the Q1 is not there, E2, E3, E4 still there because Q2, Q3, Q4 are the point charge. They are still available to provide the electric field. Okay, that's enough. Now, how about sketch electric field strength on Q2? On Q2, okay, so Q2 is the test charge. Okay, so first thing, Q2 is the test charge. So don't look at Q2. So Q1, Q3, Q4 provide the electric field. So how does it look like? How does it look like? Okay, so maybe this time I use green color. So negative Q1 is positive. Q1 is positive, so going away from Q1. So this is E1. And then Q3 is negative, so going towards negative, E3. And Q4 is negative, so going towards Q4. Going towards Q4. So this is E4 going towards Q4. So you see, when I draw electric field, I only look at the point charge. I don't look at the test charge, as though the test charge is not there. Yeah, because it don't depend on test charge. Okay. Now, how about the sketch of electric strength on Q3, experienced by Q3? So so now the test charge is the Q3. Test charge is Q3. So now I draw the electric field. Okay, Q3. Q2. Sorry, Q1 first. Q1 is positive, so going away. Positive is going away. E1. And then this is positive, so going away also, away from Q2. So this is E2. And this is negative. Negative is going towards. Negative is going towards. Negative is going towards. So E4 is towards Q4. Okay. Q4. Right. Now, yeah. Going towards Q4. Okay, that's it. So I don't look at Q3, I only look at Q1, Q2, Q3. Yeah, only depend on one charge. Now, how about electric field strength on Q4? Q4 is the Q4 is what? Q4 is the Q4 is the test charge. Q4 is the test charge. So now let us draw. Let us draw the field strength on Q4. So Q4. So Q1 is positive, going away. Sorry, going away. So this is E1. And then 2, Q2 is positive. Positive also going away. Positive also going away. And this is E2. You know, I need to draw some line to show that it originates from Q2. Okay. This is E1 is originated from Q1. Like that, huh? Okay. So now, how about negative Q3? Negative Q3 towards Q3, E3. This is E3. Okay. This field is given by Q3. That's it. Okay. Dotted line. Just draw a dotted line for the originate. So yeah. So E3 going towards Q3, E1 away from Q1, E2 away from Q2, positive away, negative towards. So that's it. That's the electric field. That's the electric field diagram. Electric field diagram. Okay. Yeah. It's just yeah. So yeah, that's it. Right. Okay. So that's the electric field strength. That's the electric field strength. So now, if you want to find the resultant field strength, so same like before, same like the resultant force, resultant force, you must draw the vector diagram. Yeah, you already draw the vector diagram. You see that? This is the vector diagram. So at last, if you want to find the resultant, you need to do like the usual, find the XY components, find the angles, find the angles, and then resolve cos theta, sin theta to get the X component, Y components, put into tables, do Pythagoras theorem to find the magnitude, and also tangent theta to find the direction. Yeah, direction. That's it for resultant, because this is a vector. Field strength is a vector. You need to use vector method to find the resultant. Okay. Now, at last, I want to explain about this. What's the difference between force and electric field? Yeah. So as I explained just now, force depends on two charge. Yeah. Okay. I write down the formula. again. force is KQQ over R square, and electric field strength is only KQ over R square. For this one is only the point, but this one force is as point and test. It has both. You see that? So force depend on two charge. It depend on two charge, Q, point and test. But electric field strength only depend on point charge. Yeah, only depend on one charge. Electric field strength only depend on one charge. Force depend on two charge. So you look at here. So what's the difference between point charge and test charge? Okay, point charge is the one who provide the electric field. Test charge is the one who experience or inside the electric field provided by the point charge. For example, now I have two charge here. I have point charge here and a test charge. Point charge and test charge, both of these positive charge. The point charge Q is the one who provide the electric field for test charge. Of course, I know that test charge also has its own electric field, but that is not our concern. Okay, we need to look one by one. Okay. Point charge is the one who provide the electric field, and test charge is inside. Look at here, compare to below here. Point charge is the one who provide the electric field. And there's big Q. Small q, Q naught, is the test charge. Test charge is inside the electric field provided by the point charge. This test charge experience the electric field given by the point charge. You see that? So now, when we want to find the force, experienced by Q naught, you need to look at both charge because the formula is QQ, double Q, Q and Q. So you need to look at both charge. Since both are positive charge, look at both positive charge, positive repel. So force is to the right because repel. But electric field is provided by only the point charge. Q naught is inside the electric field of the point charge. The test charge is inside the electric field of point charge. So you see the electric field provided by the point charge is away from point charge because it's a positive point charge. Away from point charge. So at the position of test charge, the electric field is to the right. Why electric field to the right? Because this point charge is positive. The electric field is away from the positive point charge. Okay? So force, you need to look at both charge. Same sign, repel. But electric field only look at point charge. Point charge is positive, so away from point charge. Electric field don't look, ignore the test charge. Ignore the test charge. Now, how about this one? You have a positive point charge and a negative test charge. So what happened? Okay, for force, because it's opposite sign, force you look at both charge. Positive and negative sign, opposite sign. So they attract each other. So the force on test charge is to the left because attracted to the point charge. Positive and negative attract each other. So force is to the left because attract each other. For negative, positive, negative attract. But electric field on test charge, electric field is provided by the point charge. Electric field only look at the point charge. Because provided by the point charge is positive. So electric field is going away from the point charge. So at the position of Q naught here, electric field is to the right instead of to the left. Do you see that? So it's easy. Opposite already. Force and electric field, opposite direction. Okay, so now look at this one. If you have a negative point charge and a positive test charge, what happened? Okay, for the force, look at both charge, because opposite sign, so opposite sign attract. Yeah? Unlike charges attract. So force is to the left, but electric field is provided by the point charge. So negative point charge, electric field is towards the negative point charge. So at the position of Q naught, the electric field experienced by Q naught is to the left, towards the point charge. So electric field only look at the point charge. Negative, so it's towards the negative point charge. Okay? And then, for the last one, you have a negative point charge and a negative test charge. So what happened? So for force, look at both charge, same sign. So negative, repel. See? Repel. Repel. So force is to the right. But the electric field experienced by the test charge is provided by the point charge. So this is a negative point charge. So electric field is towards the negative point charge. So electric field is to the left, towards the negative point charge. You see that? So electric field is only look at the point charge. So that is the point charge provide the electric field for the test charge. Test charge is the one who experience the electric field. So now, so you see, there's one conclusion we can see from here. You see, when is it force and electric field same direction? When is it force and electric field opposite direction? You see that? Here, force and electric field. This one also force and electric field same direction. Force and electric field same direction. But these two, force and electric field opposite direction. Why is that? Force and electric field opposite. Why is that? You see that? It is because this is the negative test charge. You see that? This is a negative test charge. That's why force and electric field is opposite. So when the test charge is a negative test charge, force and electric field is opposite direction. When the test charge is positive, the force and electric field is same direction. Why is it like that? Because look back to our definition of electric field. Our definition of electric field is focusing on positive test charge. We look at electric field is actually force per unit. What? Force per unit positive test charge. So we are using positive 1 coulomb. For electric field, to define the electric field, we're using positive 1 coulomb, positive test charge. So this force is for positive test charge. Okay? So that's why when positive test charge, force and electric field same direction, because the formula for this one is using positive test charge or positive 1 coulomb. Okay, so that's why force and electric field is same direction with positive test charge. But if a negative test charge, force and electric field become opposite direction. Yeah, opposite direction because of the definition. Okay, opposite direction. You see that? And a negative test charge, force and electric field, they are opposite direction. This one electric field to the right, so force to the left. This one electric field to the left, so force to the right. So opposite direction if negative test charge. If positive test charge, force and electric field same direction, or towards right or towards left. Okay, so that's it. The difference between force and electric field, and also, so remember, force look at both charge, positive, repel. Electric field look at the point charge only. If positive, going away. If negative, going, if it is a negative, going towards. Okay. And this one, the force, look at both charge, opposite, so attract. Electric field, just look at the negative test charge, like negative point charge, so towards the negative point charge. So that's it for electric field. So the next part is going to discuss about electric potential and electric potential energy. Thank you. Bye.